Now we move on to our last section within sets, which is problem solving with 3 sets. So the first example we have here is one where a Venn diagram with 3 sets is already filled out for us. A group of transition year students were surveyed and asked whether they watch TV, read, or sketch to relax. The results are displayed in the Venn diagram. So the first thing we need to do is figure out the number of students who participated in the survey. So these questions all involve cardinal number. So these numbers in square brackets indicate the number of students who do each thing. So we can see, for example, if we look at this 13 out here, that 13 is outside all 3 Venn diagrams. That means there's 13 students who do not read, watch TV, or sketch to relax. So there's 13 students outside that don't belong to anything. Then, for example, here we have 3 students who do all 3 to relax. And another, for example, here is we have 21 students who only watch TV to relax. They don't also sketch and they don't also read. Then in here with the 11, we have 11 students who read and sketch to relax, but don't watch TV to relax. So the very first question that we've been asked is figure out how many students participated in the survey altogether. So we have to add together all of these numbers. So we have to add together every single number there. So give me 1 second. So I have 7 plus 3 gives me 10, plus 21 is 31, plus 6 is 37, plus 11 is 48, plus another 16 to be 58 and 64. Then 64 plus 13 would be 77, and 77 plus 18 would be up to 87 and 95. So we have 95 students participated in the whole thing altogether. Now I'm going to realistically double check that and delete the video if I got that wrong. Using the Venn diagram, find the number of students who relax by reading. So total number of students who relax by reading, well, they're going to be in here. So they relax by reading. So we have 6 plus 18 plus 3 plus 11. So 6 and 3 is 9, plus 11 brings us to 20, plus 18 brings us to 38 students read to relax. Then the next question asks us how many sketch to relax. So then we have to go 7 plus 3 is 10, plus 11 is 21, plus 16 is 27 and 37. So 37 students sketch to relax. Then how many students relax by watching TV? So then the number of students that relax by watching TV is 21, plus 7, plus 3, plus 6. So 7 and 3 again is 10. Add that to the 21, we get 31, and add it to the 6, we get 37. Now, very unlikely in this day and age that you have more students relaxing by reading than watching telly. Then how many students relax by watching only one option? So we have 21 that only watch TV, 18 that only read, and 16 that only sketch. So we have 18 and 16 is 34, add the 21, that brings us to 55. So we have 55 students who only relax by doing one of the options. Then the next one asks us how many students relax by doing 2 options only. So we have 7 that watch TV and sketch, we have 6 that watch TV and read, and we have 11 who sketch and read, but they don't do all 3. So we have 6 and 7 brings us to 13, add the 14 brings us to 24. So we have 24 students who do that. Our next example is about a school PE department having to pick a new tracksuit, and the school colours are blue, white and red, and the tracksuit must be at least one of these colours or a combination of them. So we have 142 students wanted all 3 colours, 231 wanted blue and red, 205 wanted blue and white, 41 wanted white and red only, 321 wanted blue, and so on. So you have to draw a Venn diagram to represent this information. So our Venn diagram I have set down here, and our first step is to fill in the cardinal number for members that are common to all 3 sets. So our 3 colours are blue, white and red, so I'm going to name my sets blue, white and red. So let me see, 142 wanted all three. So 142 goes in there. Then we had 231 wanted blue and red. So that's 231 altogether wanted blue and red. So what we have to do is we have to say, well, if there's 231 altogether wanted blue and red, that's 231, and we have to subtract 142 from it. So that will leave us with how much? Let me see. So 231 minus 142 is about 90 or so. $89. So we have 89 in between 4 blue and red. Then we had 205 wanted blue and white. So we have 205 minus 142. Yeah, that's 63. So that's 63 for white and blue. Then how many for white and red only? So we had 41 for white and red only. So that was actually given to us. So that's just straight up 41 in there for white and red only. Then 321 wanted blue, 256 wanted white, 52 wanted red only. Well, the 52 to want red only can go there. But then we have 331 students wanted blue. So 330, yeah, no, 231. Sorry, 321. So we have 321 for blue. So that 321 for blue is going to be 321 minus 142 minus 63 minus 89. So again, you just do this in your calculator if you want. I'm a little bit tired, so I will not be doing that in my head. So it leaves us with 27 that want blue on its own. And then we have 256 wanted white. So 256 minus 142, 41, and 63. So that's, take away 6, leaves it 0. That's 8 and 14, 24. So it's 10, is it? Let me see. 2, 5, 6. Yep, so there's a 10 only for there. Now, see, does the question say anything about students who didn't want any of the three colours or anything? No, so there's going to be no one in the universal set outside our three sets. So draw a Venn diagram to represent this information. So we have that done. How many students wanted only one colour in their tracksuit? So we have, this is part 2. So the students only wanted one colour, whereas the 10 that only wanted white, 27 that only wanted blue, and the 52 that only wanted red. So that brings us to 62, 69, 89 students only wanted one colour. Then for the third one, how many students are in the school? So how many students are in school? That means we just need to add all those together. So again, calculators out, make it a small bit easier on ourselves. So 52 plus 41 plus 42 plus 89 plus 27 plus 63 plus 10. So I have 324 there. Now I'm after doing that very quick, so I might have done it wrong, but now in our third example, a survey is carried out of 200 first-year art students at a university. Okay, so the very first thing I'm going to do is I'm going to write in the universe is equal to the 200, because that's, I'd be likely to forget that because that was just the very first detail we're given. We have 76 study English, 62 study history, 81 study maths. So I'm going to go to my Venn diagram and will have, so we have 76 for English. So that's the total for the entire Venn diagram. Then we'll have 62 for history. So I'll put in a H for history and a 62. And then we'll have 81 for maths. Wouldn't you know, the person writing the maths book makes maths the most popular subject. We have 18 don't study English, history or maths. So that 18 is going to go on the outside of our Venn diagram. We have 11 study maths and history, 16 study history and English, 18 study maths and English. We don't know how many people study all three, because the question is stipulated that X study all three subjects. So we have to try and figure out how many students study all three by the looks of it. So first off, we'll have to fill out our Venn diagram as it is given to us. So first things first, we've already filled out the intersection of all three. So now, we've been told 11 study maths and history. So we have 11 that study maths and history all together. So that's 11 that study maths and history that go in here. So that's 11 students that study maths and history in there. But we don't know how many of them study maths and history, but not English. So what we'll have to say is, well, we have 11 students study maths and history all together. And if we take away X, the unknown amount that study all three subjects, we'll be able to figure out how many only study history and maths. Next then, we have 16 study history and English. And the same as before, we know there's 16 altogether that study both subjects. We'll have to take away the students who study all three. So for history and English, we'll have to take away X. So we'll have 16 take away X. Then we have 18 students that study maths and English. So that's again going to be 18 take away X students. Okay. Now there's been nothing else given to us in the question that I haven't filled in on the Venn diagram. Now the next thing we want to try and figure out is how can we represent the number of students that study only one of the subjects. So let's think. We have 81 altogether that study maths. So we have maths here is equal to 81. So we have 81 students study maths. And if we take away the 11 minus X, and we take away the students who study all three subjects, and if we take away the students who study English and maths, so we have the 81 that study maths altogether, and we're taking away 11 minus X, that's minus 11, plus X, minus 18, plus X. So the plus X and the minus X there will cancel each other out. Then we have 81 minus 11 will give us 70. So then we have 70 minus 18 plus X. So 70 minus 18 leaves us at 52 plus X. So we have 52 students plus X that study maths only. Now we want to do the same thing for English. So we have English altogether is equal to 76. So there's 76 students study English. We'll have to take away the 16 minus X, take away X, and take away 18 minus X as well. Now be careful of your brackets here because it'd be very easy to forget to do it properly. So we have minus 16 plus X, minus 18 plus X. Remember, your negative by negative is positive there. So 76 minus 16, well, that'll leave us with 6. Oops, no, that'll leave us at 50, not 60. No, sorry, I was right, 60. Then we have a plus X minus an X, well, they'll cancel each other out. Then we have minus 18 plus X. So then we have 60, take away 18 is going to leave us with 42 plus X. So we have 42 plus X students that only study English. 42 plus X that only study English. Now again, I just have to keep the square brackets around these because that means the cardinal number. Then the very last one is for history. So we have history is 62 students. So we have to say, well, we have 62, take away 16 minus X, take away X, and take away 11 minus X. So that's 62, take away 16 plus X, minus 11 plus X. So we plus X minus X, cross them off. Then we have 62 minus 16. So 62 take away 10 would leave us at 52. Take away another 6 would leave us at 46. So 46 minus 11 plus X. So that'll leave us at 45 down to 35. 35 plus X students in here. So that's 35 plus x. Okay, now that is part one of the question done, because we have successfully drawn a Venn diagram to represent this information. So we've represented everything they've told us on that Venn diagram. Now the next part of the question wants us to figure out how many students actually study all three subjects. So it's effectively finding out how many students in total study all three. So it's finding out the value of the variable x. So how many students study all three subjects? So we have to look at our diagram and think, right, the information on this Venn diagram as it is there currently, could we figure out how to do this? So I want you to pause the video here, but I want you to think about, is there any algebraic equation you could form to figure out the value of x? Is there any way we could figure out how many students there are all together here? So have a think about that, pause the video, and then press play again. So some of you may have figured it out. So we know that there are 200 students all together in our universe that did this survey, I think it was. And we know that we were able to represent those students using x. So we have 42 plus x that only study English. We have 16 minus x that study English and history. We have x that study all three. We have 18 minus x that study maths and English. We have 52 plus x that study only maths. 11 minus x that study maths and history only. And we have 35 plus x that study history only. So let me run through that again. Oh yeah, and what I've also forgotten was we have 18 students who don't study any of those three. So we know that if we added all those together, we'd have to end up with 200 students altogether. So let me run through it again, make sure I haven't forgotten any. So we have the 42 plus x, 16 minus x, x, 18 minus x, 52, the 11, the 35, and the 18. Yeah, so we have everything included there. So now what I'll have to do is I'll have to run through and simplify the left-hand side of that equation. So I have an x here, an x here, an x here, an x here. I'm just marking off all my x's. Okay, so I have a plus x and a minus x. So that one will cancel that one. That plus will cancel that minus. That plus will cancel that minus. And we're left with a solitary positive x. Okay, now I'll run through and add all my numbers together. So I'll have 42 plus 16 be 58. Then I have to add 18, add 52, add 11, add 35, and add 18. And we're left with 192. So that's plus x plus 192 is equal to 200. Well, to balance this equation, we know what we have to do. We have x plus 192 is equal to 200. And if I want to solve an equation, I need variables on one side and numbers on the other. So I'm going to have to subtract 192 from this side of the equation and subtract that 192 from the right-hand side as well. Then I will be left with x is equal to 8, because these two cancel each other out. And 200 minus 192 is 8. So we have x students that study all three subjects in the school. Okay, that's our third example solved. Now you can pause the video, and on the one